So we're still staying on track of using pointer to an integer to access array elements, and trying to use this function here to demonstrate. This function could be rewritten as follows. Instead of using the for loop and using index and using subscript access to individual elements in the array, instead I could do this. A while loop, which simply says while the size, I can just copy and paste, I guess, to not to make any typing mistakes here, right? While so this is like version 1, and version 2 right here is would be saying that just use pointer dereference operator, which is, by the way, exactly as this, right? So writing this means exactly the same thing if you wrote this, okay? So it's just essentially using subscript 0 instead of any other subscript, which will give you basically take this address and dereference it, provide access to that location in memory, and we can, I don't know, initialize it with 1, 2, 3, 4, 5 for the sake of demonstration. But this case, every time it happens, you just increment the pointer and say, okay, move this pointer to the next element in this array. Of course, size of an array is given initially as 100 or some other value. In this case, the size of an array needs to be decremented so that we have a way of bringing this down to 0, and as soon as this becomes 0, we exit the while loop. So there's another possibility of doing this. Perhaps, some people find this much friendlier. Some people might find this to be a friendlier version of coding. I am not going to elaborate on this right now, but clearly this is using sort of like pointer arithmetic or pointer navigation to say, instead of using pointer as a base address and use array syntax to access memory pointed by this pointer, instead use pointer as a variable and navigate this address to the next one, to the next one, to the next one, right? So this says move to next int in the block of memory that we were giving, right? This was given us as the beginning of a block of memory. It contains integers apparently, and so we're free to go ahead and initialize the information there. Over here, by the way, I could use the size of an array to to store it because it kind of changes in a loop. That's another possibility to initialize the content of the array with something interesting. Any questions about this so far? The most important part was that we created a block of integers, otherwise known as array, which is a very primitive facility because, look, to populate this using by some useful piece of logic encapsulated inside this function, you have to provide the size. The function, there's really no way by passing a pointer to a memory, there's no way to bring in the size automatically. You really have to supply the size on your own. Now remember where we started. We said, okay, we just did some demonstration here. We were able to use an array just like this one inside our stack. We said, okay, some initial size, let's create it as part of our object, and then start using it by pushing and popping values in and out. All right, the next stage is that we want to move away from this limitation on primitive arrays that they require constant size. In other words, the size which is known at compile time. What if at runtime we find out that we need 2 times this size, right? So we're in trouble. We need to allocate this array dynamically. a typical, and I'll use perhaps my PTR variable, which I never initialized. So I may try something like this. PTR, which is a pointer to integer, right? It was declared as pointer to integer. It wasn't really initialized. One of the possibilities is to initialize it with null, which is just a 0. By the way, null. So let's quickly find out where the null comes from. So we go to something like c++.com, right? And quickly search for a null. Right here, just say null and say go and search, and it gives us that the null macro, which is a macro, which is like a preprocessor symbol, which is defined as 0. We can go to any of these headers which it is guaranteed to be coming from. So we're going to perhaps use this one, right? So Control C, and in order to make it available to our program, we have to say include and just paste this, right? So C++ standard header std_def includes null in its it includes the definition of null. All right. So null is simply agreed to be a 0 address, the address which has all zeros in it. And C++ standard says that even if a memory address with all zeros in it is a valid address, we're going to sacrifice it to declare we need some address which would be understood by the programming environment, by our language, as an illegal address, right? So address with all zeros could be still a legal address in physical memory, but we're going to sacrifice it and always expect that the null pointer is a pointer specifically initialized with all zeros to indicate that it's not pointing to anything real, right? But you don't want some random address to be in it. You really want to control what's in it. So null is one of the choices when you want to create a pointer and not really give it any particular address just yet. So the next thing is, if we want to move away from a statically allocated array, we have to use the new operator. And we have to say new what? You can say new int. New int will allocate one integer, just one integer. This is not so practical with integers, but if we wanted to create, to declare an object, a class, name it somehow, and then say new, and create brand new object at runtime, that would be much more practical. So with integers, most likely we want to say, this is how you allocate an array dynamically. This time, there is no name. There is no name. It's dynamic. This block of memory is nameless. All we get back from new, which we have to tell the part of the syntax of new, is to new says, I can give you brand new block of memory at runtime, but you have to tell me what is the type of that memory and how many elements you want to allocate. And so new returns back an address of this brand new integer array. Now this can be a variable, right? This can be size. And we can, so size can be declared as int size equals 100. So truly it's a variable and it can change. We can ask user whether they want to change it. So this now truly becomes a dynamic array in terms of what type of what type of elements you want and how many. If this happened to return, if there is no memory to allocate 100 integers, it will return null. And so your pointer will get a null. Okay? So typically then you can say, there are other ways to deal with this, but one of the ways is to say, if pointer is null, right, that would mean that no memory available. Okay, and whatever you do at this point is your choice. Okay, so if it fails, if new fails at runtime, this is what you get. You basically get a null pointer back, and it indicates to you that hey, it didn't work, right? But I mean, it's a it's something that you can remember to program defensively. All right, but at this stage, and I could like use a bigger number here, like maybe 1,000 to just to make a difference here. So and then again use a variable here to populate it, right? When I call my populate array function. So this truly demonstrates the creation of array at runtime. This is this part right here that we say, give me this chunk of memory, right? If we're trying to construct our stack and we're trying to give it access through some pointer here, access to dynamically allocated memory, the true picture is this. This is located someplace. This is located somewhere else. These are two parts of memory that simply one of them knows about the existence of the other one and is actually using it, right? So this is really dynamic memory allocation. And so let's save this section.